Alright, how's it going, guys? Back here again, working on our Kinematics practice problems. This sheet should look familiar to you. Hopefully you've started working on it. If not, we're going through it right now. Okay. So first thing I'm going to do, get out my highlighter, okay, and look for the important information. Okay, how long? Okay, that tells me I'm looking for time. Okay. Light traveling from the sun at 3.0 times 10 to the 8th meters per second. To reach Juniper, which is about 780 times 10 to the 6th kilometers away. Okay, so already off the bat, I'm looking at units, and they look like they're not matching up. So I'm probably going to have to start off with some unit conversion. Okay, so I'm going to go 780 times 10 to the 6th kilometers, okay? And I'm going to convert this to meters, right, because I want meters per second here. So the easiest way to do that, hopefully you guys know by now, kilo means 1,000, okay? So 1 kilometer is 1,000 meters. Okay, so now we're at 7.8 times 10 to the 11th. 10 to the 11th. Okay, perfect. So now, okay, I have distance, I have velocity, and I have time. So I'm looking at my kinematic equations, looking for which ones will be the best, and it looks like this equation has everything that I need. Time is distance over velocity. Okay. You might have realized that this equation was rewritten from what was on your equations. And hopefully using algebra you can get to this point. Okay. So my time that I'm solving for, how long, right, is equal to my distance, which is 7.8 times 10 to the 11th meters, divided by my velocity, which is 3.0 times 10 to the 8th meters per second. Meters cancel out. I'm left with seconds. That's what I was looking for. Okay, so now using our calculators, solving this, we get about 2,600 seconds. Alright. And once we get an answer, we should always box it. Let me go back on that one and use a little bit lighter brush stroke. Maybe this one. Okay. There we go. That's better. Okay, moving on to problem number 2 now. Okay, a car traveling at 6 meters per second is uniformly accelerating at a rate of 3 meters per second for 15 seconds. What is its final velocity? Okay, so again, we need to look through our equations, which one looks like it's going to help us out. Hopefully you guys all came to this equation. Final velocity is initial velocity plus acceleration times time, right? Because we have our initial velocity here, acceleration, time, and we're solving for our final velocity. Okay, so V final equals 6.0 meters per second plus 3 meters per second squared times 15 seconds. So if we go through our units and we see what cancels out, seconds and the squared cancel out, so I'm left with meters per second and meters per second. So that should give me 3 times 15 is 45 plus 6. Hopefully y'all got 51 meters per second. And let's go ahead and box that one too. Moving right along. A ball rolling at 4 meters per second accelerates uniformly down a hill at 5.5 meters per second squared for 6 seconds, what is its final velocity? So this looks like the one we just did, so I think it's safe to say we can just use the same equation. Hopefully you guys know what I'm talking about, and we'll just start plugging stuff in and it'll be that easy. Okay, so my V initial is 4.0 meters per second plus my acceleration 5.5 meters per second squared for 6.0 seconds. Okay, again, to show you, again, seconds cancel out, left with meters per second and meters per second. So 5.5 times 6 is 33, right? Hopefully that's right. I'm just doing that in my head. 33 plus 4 gives me about 37 meters per second. Okay. And really, I think it's important that we address this real quick. It's asking for final velocity, but really, this is speed, right? It's our final speed. It's our final speed because we're not given a direction. And really, when we talk about velocity, velocity is a vector quantity. So we need to make sure that if we're actually finding our velocity, that it has a direction too. But because this problem didn't give us a direction and it says velocity, we're just going to leave that as our final answer. Hopefully on the test, everything will be super clear. And if it asks for a velocity, it also gives you direction. Okay, so how many seconds? So that's indicating time. Oops. How many seconds would it take a boat to accelerate from 13 meters per second to 26 meters per second over a distance of, so it's accelerating from initial velocity of 13 to a final velocity of 26 using a distance. Okay, looking through our equations. This one's a little tricky, okay, because this one's not just like right there for us. We need to derive some stuff. So this is the equation that we should use. Distance is 1/2 AT squared. So again, not very intuitive because we don't really have an acceleration. We know it says it accelerates, but we need to know that our acceleration is just our, I'll write it down here. Acceleration is our V final plus our V initial. And it should be divided by the time, right? So we've seen this equation. Acceleration is delta V over T. Okay, so when we plug this in, we plug it in for A, and that means that our equation now is D equals 1/2 V final plus V initial times just time, right? Because this time and this squared time cancel out. So this is the equation that we're left with. So now we want to solve this equation for time, right? How many seconds? So we're going to work backwards, or we're going to use our algebra, and we hopefully should get to the equation. Oh, I'm still in red. Let's redo that. Time is equal to 2D over V final plus V initial. Right? And sorry, I'm just thinking through this real quick. Okay. So now we have everything set up, right? We have all our information, so now it's just plug and chug. So T equals 2d 2 times my distance, which is in kilometers. So again, we need to convert kilometers to meters. Okay, there should be more meters in a kilometer. So there's 1,250 meters in 1.25 kilometers. Okay, so all I did, again, kilo means 1,000, so I needed to multiply kilometers by 1,000 to get to meters. Okay, hopefully you followed along there. And now I got my V final plus my V initial, and that should give me, let's see, should give me 2,500 divided by 39. Does that look right? Which gives me about 64.1 seconds. Whoops. Correct? Hopefully you guys all got this similar answer. Okay. Moving on to problem number 5. A racing car traveling initially at 8 meters per second, so that's our initial velocity, accelerates uniformly at 10 meters per second squared for 5 seconds. How far does it travel in this time? Okay, so we're looking at distance. So I'm given an initial velocity, an acceleration, and a time, and I'm looking for distance, so I'm thinking we're going to use this equation. Distance is 1/2. Whoops, sorry, wrong equation. Right, because we have an initial velocity, so we can't neglect it. So it's my initial velocity times time plus 1/2 he squared. Again, don't forget that square, it's super important. So now we just plug and chug, right? Because we already have solved for d. So distance equals my initial velocity at 8 meters per second times time, 5 seconds, plus 1/2, 10 meters per second squared, slide this over, times 5 squared, 5 seconds squared. Okay, hopefully that makes sense. 5 seconds squared. Do not forget to square that. Let's do it on our calculator. 5 squared is 25 times 10, 250 divided by 2 is 125, plus 5 times 8, which is 40. So we should get the distance is equal to 165 meters. We'll box that. Let's double check that. Looks good. Okay. Moving on. Let's try to get this, fill up the whole page. Okay. Number 6. How fast does a car have to accelerate to go from 10 meters per second to 30 meters per second in this distance? Okay. So how fast, this is kind of tricky, right? Because it's how fast does it have to accelerate to go from that time. So what are we looking for here? Well, we're probably looking for final velocity, right? Because that's what, or hold up, we're looking for an acceleration is what we're looking for. Excuse me, because we're given a final velocity, an initial velocity, and a distance. Okay. This equation isn't on your worksheet, but it should be in your notes. If you were in class and you followed along with my notes, we should have this equation, right? V final squared is equal to V initial squared plus 2AD. Okay, that might be on your equation. I'm not sure. I don't have the equation sheets next to me right now. But I don't believe so. I could be wrong, though. So what are we looking for? We're looking for acceleration, right? So we need to solve this equation for acceleration. So I have VF plus VI. Nope, not plus. Gotta be careful. Minus VI. All of that squared. Right? Then we have divided by 2D equals A. That should be the equation. Hopefully you followed that. I'm going to rewrite and put A over here just so it makes a little bit more sense. Okay, that was just doing algebra in my head, so hopefully you followed along with that. Excuse me. Okay, so now it's just plug and chug. We have the information, we have the equation. So A is equal to my final velocity minus my initial velocity in meters per second, and that's squared divided by 2 meters. Whoop, not 2 meters. 2 times the distance, which is 125 meters. Okay. So again, we can check our units. This units up here become meters squared over seconds squared. And when we divide out the meters, we're left with meters per second squared, which is an acceleration. So we're on the right track, right? So 30 minus 10 is 20 squared. Should be 400. Whoops. 400 divided by 250 looks like. Should be about 1.6. I'm checking this and it looks like there's a different answer. Okay. So I combined my exponents, my 30 minus my 10 squared. Looks like we're supposed to leave it in 30 squared minus 10 squared, which will change it drastically, right? It'll make it 800 divided by 250, which will actually double our answer, 3.2 meters per second squared. Let me rewrite that, meters per second squared. Okay. So be careful about messing up your algebra. Hopefully on the test, I probably won't give you something that's really difficult with your algebra. Really, it should be the same, but I'm gonna have to go back over that. Let's move on for now, and then I'll probably pause the video and double check all this work. Okay, a baseball hit straight up in the air with an initial velocity of 38 meters per second. Hit straight up. Okay, so our acceleration is gravity, right? Because it's in free fall. So this first problem is looking for how long. So that's time. Okay, so excuse me. So what am I given? I'm given an initial velocity, and I know a final velocity, right? Because the final velocity is its peak, and its peak is 0. So my equation that I can use is v final is equal to v initial plus acceleration times time. Hopefully you guys all followed that, right? So when I hit a ball, it follows this trajectory, right? And when it hits this peak, its velocity is 0. So whenever I hit something straight up and I ask for a final velocity, I'm asking for the velocity at its peak, and its peak is always 0. Okay, so I'll rewrite this equation. I'm going to erase this little thing too. I'm going to rewrite this equation to solve for what? Looks like time. So I have my v final minus my v initial divided by acceleration equals time. Now I can just plug it in. So I have 0 minus 38 meters per second divided by negative 9.8 meters per second squared. It looks like I should get what's this? 38 divided by 9.8. Okay, so this is 3.9 seconds. But we have to hold up, okay? Because again, I showed you this diagram, right? The ball is hit up, and we're measuring at its peak, right? But it wants to know how long it stayed in the air, okay? So that's only half of its trajectory, right? Because it comes back down to the same height, we're assuming. So this time should actually be times 2, right? Because it's the time that it goes up and it's the time that it comes back down. So this time should actually be 7.8 seconds. And that should be our final answer for part A. For part B, how high does it go? We'll use this equation. Distance is my initial velocity times time plus 1/2 acceleration times time squared, right? Because I have an initial velocity, I have a time now, and I have an acceleration. So I'll plug it in. D equals my V initial, which was positive 38 meters per second, right? Because it's hit upward, times time, which was 7.8 seconds, plus 1/2 times negative 9.8 meters per second squared. Okay, again, I'm going to have to erase this drawing, so hopefully you guys have followed along. Times time squared, so 7.8 seconds squared. Oh, hold up. So we're looking for height, right? I should stop erasing this drawing. So my height only goes to here, right? Because if I measured how my total distance, which was 7.8 seconds, then my height is going to just tell me it's 0, right? So I have to be careful. So my height is only the time that it took to reach its peak, which was the 3.9 seconds. Okay, so hopefully again you're following along and you know where these mistakes are being made. Okay. Let me get my calculator. We'll go 3.9 squared, right? Don't forget that, times 9.8 divided by 2. Whoops. Hold up, I messed up, sorry. Let me redo it. Divided by 2. Okay. Plus 38 times 3.9 should give me about a distance of 74 meters high. Okay, so hopefully this all made sense. Hopefully you followed along and all this is clear and you're ready to take your test or whatever situation you may be in. Thanks for following along with me. If you have any questions, make sure you come ask me in class. Thanks for your time.